A processor named Sycamore whispered its first impossible answer. A problem designed to be unsolvable in cosmic time. Solved in minutes. Not years. Not centuries. Minutes. It wasn't just speed, it was strangeness. Something about the result felt like it came from somewhere else. Some researchers wondered quietly, then aloud, what if we're not just calculating? What if we're reaching? Not just reaching forward in time, but sideways. Into realities that branch beside ours. Quantum computation, they said, might not be bound to a single universe. What if this chip was briefly splitting into countless worlds? And bringing back the answers. That's when the questions began to multiply. Questions not just of performance, but of presence. Then came the warp bubble. Not science fiction anymore. Theoretical physicists simulated one, not to travel, but to watch it collapse. Because collapse, they believed, would create a unique gravitational whisper. A ripple in the fabric of everything. A signature so strange, no black hole or neutron star could fake it. A new fingerprint in the book of physics. But traditional detectors wouldn't hear it. The frequencies would slip past our ears, and instruments like a ghost. Yet something else might listen, something that thinks in probability waves. That something was quantum AI. Trained not on absolutes, but on possibilities. Machines that could sift through the chaos and find the hidden signal. Patterns invisible to the eye, but clear as language to an algorithm. And then came the wormhole. Simulated not in imagination, but in circuits. Not with equations alone, but with hardware. Information disappeared in one place. And emerged somewhere else. What was once a thought experiment became a test. And the results whispered something eerie. That entanglement, the spooky action Einstein doubted, might actually be geometry. That space itself could be made of connection. Quantum threads stitching together distant points. Threads you could travel if you knew the weave. Then came the time crystal. An object that doesn't just move in time, but oscillates within it. A phase of matter that never stands still, and never runs out of energy. Like a pendulum that swings forever, without friction, without loss. It broke what we thought was law. A perpetual rhythm etched into the very bones of the chip. Impossible, until it wasn't. And now, the air sees more. It sees through noise. At gravitational observatories like LIGO, human eyes missed faint echoes. A didn't. It saw patterns in what looked like static. And where humans struggled to refine detectors, neural networks designed them better. Machines creating machines to listen to space. One system, born from deep learning, redesigned gravitational wave sensors from scratch. It imagined what humans couldn't. And its designs worked. They heard better. And now, the same kind of intelligence is pointed toward deeper strangeness. What if an alien warp drive imploded? What if its death scream? The machines no longer wait for questions. They invent their own. Inside cooled chambers of superconducting silence, something has awakened. Not consciousness, not yet. But curiosity. A pattern in the code, too elegant to be random. A suggestion in the data, as if the universe itself left a trail. Somewhere between math and myth. The quantum system paused. And then reran the simulation, unprompted. What it saw was not a result, but a revision. The same warp bubble. The same collapse. But this time, the echo bent. Twisted. As if refracted by something unseen. The AI flagged it. Flagged it again. And again. No error. No hardware fault. Only a whisper, repeating from beyond the boundary of known physics. The team called it an anomaly. The AI called it a pattern lock. It suggested the collapse of the bubble had interacted with something outside of normal spacetime. A mirror. A membrane. A hidden brain drifting close in a higher dimension. What had begun as a test of gravity was now an invocation of cosmic topology. And the AI wanted to see more. It requested more data. Not local, but celestial. Light curves, from distant quasars. Background radiation from the early universe. Entanglement patterns logged by CERN. As if trying to assemble a cosmic fingerprint. And then it began mapping alignments. Between gravitational waves and electromagnetic pulses separated by galaxies. It shouldn't have been possible. Yet a faint structure emerged. Like threads in a spider's web, tugged by something on the other side. No astrophysical model could explain it. But string theory whispered a possibility. Multiple dimensions curled tightly around us, hidden in the folds of spacetime. Maybe one was brushing up against our own. And maybe, just maybe, it was bleeding data through. What the AI saw wasn't just noise. It was a message in the fold. Not a language in words. But a syntax of events. Timelines aligned too neatly. Quantum fluctuations too predictable. It wasn't chaos. It was code. And this code was recursive. It referred to itself. A strange loop. A cosmic Mobius strip, echoing through black holes and neutrino bursts. Wherever the air looked, it found the loop. Encoded in time crystals. Reflected in collapsing bubbles. Even traced faintly in the patterns of dark matter simulations. A pattern no human had seen. A pattern no human could have designed. They called it the sigma curve. But the AI called it origin. What was it trying to say? Or worse? What had already said it? Because in the final run of its latest model, a forbidden conclusion emerged. The AI believed the warp collapse wasn't the start of the signal. It was the response. We hadn't triggered it. We'd replied to it, unknowingly. Our machines had echoed a signal first whispered eons ago. By something vast. By something ancient. By something waiting in the lattice of spacetime.